Assalamualaikum warahmatullahi wabarakatuh. For the next 2 weeks, we will learn about the Arduino programming. So basically, I'm trying to focus more on the simulation aspect of the programming, in which how we can develop our own environment of programming using the Arduino, and then what is the main pillar of the programming that you need to know to ensure that you can develop your own system. So, but basically, I have developed some simple applications for controlling robot hand by using the ESP32. So, in this case, this is the ESP32, and then we attach two buttons here. So, the first button is for open the grip, and then the second button is to close the grip. So, basically, for the robot hand was actually equipped with the servo motor. So all the things was actually connected to the ESP32 board. So we will discuss about this board later on when we go to the sensors and actuator part, and also the IoT application implementation. But for now, this is some sort of the application. So once we press some of the button, so the grip will be open, and then once we press another button, it will be closed. So when using the IoT, we can control the movement of this robot by using the Blink or whatever IoT dashboard. So basically, for this particular programming part, so I use this simple programming structure, which is, in this case, I use the pretty standard Arduino IDE. So this is the programming part. So it's quite simple, it's quite straightforward. So for the Arduino IDE, so once you open the new file, so basically this is the first screen, in which you will have with this basic code structure. So for the Arduino code structures, the first part, which is the setup. Setup means that this is the part of the code that will executed once you switch on the Arduino. So this part only will be runs once, and then second part, which is the loop. Loop means that this is the infinite loop. So it means that most of your programmings shall be located in the main loop, so that it will be executed during runtime. So another part, which is some of the important function for the Arduino, means that so we have we will go into the details about the programming of the Arduino later on. So for this particular case, one of the important things regarding the Arduino is the port setting. So for this case, so let's say if I connect my ESP board, so you will see some port information appear. So for this case, the port is the port 6. So this is the first setting that you need to do to ensure that you can run the code. And then second thing is that one of the part that is important is in terms of the board manager. So board manager is the part that you should setting when you use different type of the board. So in this case, we have the Arduino Uno, Arduino Mega, and etc. And then the same thing with the ESP32. So ESP32, we have many type of board. So for the board that I use just now is actually based on the ESP32 development module. So if you wish to know what type of board that you want to select, so you need to look at the back of the board. So it will stated what is the type of board that you can use. Anyway, we will go into the details this part later on when you go to the input output setting. So the first thing is the port. Second thing is the board selection of the port, and then secondly is the selection of the board. So we have two part here. So the first part is the verify, and then the second part is the upload. So basically for the verify, so once you click the verify, so it will give you some sort of the compilation of the programming, and then the status will be appear here. So once in this part done compiling, so once the everything is compiled accurately, so the next part we can upload the program straight away to our microcontroller. So for this particular case, since we use the ESP32, so we need to press the boot button in the board so that the program can be uploaded successfully. So once the data was loaded, so afterward we can release the button. So you will learn about this part later on in details in terms of your lab. So what I want to focus for this class session is that we will use some sort of the simulation software. The aim is that to improve your knowledge or understanding in terms of how we can do the Arduino programming, the concept, the connection, and etc. So since this is more on the class session, so we will do everything more on the simulation aspect. So I will introduce to you one of the software that can be utilized to ensure that you can learn better, you can polish better in terms of the programming aspect. So basically this is the part that we will cover up today. So means that this is the big six concept in the programming in terms of the Arduino. You can find this note inside of the folder. So basically what you will learn today is in terms of the digital write, how we will do the digital write, and then digital read. These two part we will cover these two part first, but later on we will learn about the analog write, which is this is the digital to analog converter. So let's say you want to dim the light, so what is the command that you should send to dim the light. And then this is the first three, how we able to 1 2 3 4 is how we able to read and write, input and output. And then another part is the if statement. If the statement is the conditional situation in which how you can actually control some sort of the condition based on the given input condition. Another part is the serial communication. So serial communication in this case is quite important. Let's say if you want to connect multiple boards, or if you want to see the current status of the board, you can use the serial interface to show what is the current status of the board. So let's go into the details of the software that you will use to learn the programming. So the name of the software is Tinkercad, tinkercad.com. So we will use this software to learn more about the connection. The first thing is in terms of the connection, and then second part is in terms of the Arduino programming. So you can create your own account first. It's just a simple process. You can just sign in using the Google account straight away, and then select your Google email. So once you do the login, so you will see this interface. So this is the first dashboard that you will see in terms of the Tinkercad visualization. So once you are in this the dashboard, go to the left side and then click the circuit. So we will do the programming based on this particular platform, which is the circuit. So just create the new circuit. Okay, so once you create the new circuit, so you will have this dashboard interface. So in which for this dashboard interface, in the most right side, you will have most of the components. You can select what type of component that you want to use. So basically we will use either the this is the basic component, So you can select the Arduino board, and then we have some circuit assembly. But for our first part, we will try some sort of the simple Arduino connection. We will add more part in the Arduino, and then later on how that thing can be related to the coding. So this is the board, and then second part is in terms of this part. So this is where you will rotate the components. You can delete the components. This is more on the, you can undo the step that you have taken. So for this part, this is where you want to put the label or annotation in each part of your setting. And then this part, so we'll have the coding part, in which the interface will be almost the same with the Arduino interface. So the coding will be the same, but it will be execute just on the screen instead of we need to have some Arduino. Start simulations means that once everything is according to your expectation, you can start doing the simulation. So let's try a very simple one. So before we can move further, so let's say for this case, I just select the first one, which is the blink. So you can simply drag the components, and then in this case, the LED of already wired up for you. So in this particular Arduino board, so the LED was connected to the pin 13 of the GPIO, general purpose input output, and then another part of the LED connected to the ground. So it means that we will power up here using the port 13, pin 13 to light up the LED. So once you drag that thing, so the code is already written for you for this case. So there are some option in terms of the coding, the block coding, blocks plus tag or the text. So for this class, we will just focus on the text coding, because of usually for the block codings will be more on the secondary or primary school. So because it's more on something like how you can stack the block to create the programming. So we will focus on the text programming. So means that the interface is almost similar with respect to the normal Arduino IDE. So this is the Arduino IDE. So this is what you see in the simulation, and then the setup, everything will be the same. So for this case, in the programming, so for the setup, so let's say in every component that you install to the board, so you need to do some sort of the three step. The first step is that you need to tell the Arduino the connected part is the input or output. So you can set up the thing here. And then the second step is that if its output is straight away, means that you can just power up that thing straight away. If it is input, then you need to have some command in order to read the input state, and then later on based the input state what the system should do. So I will show you later on, but for this case, let's focus on the simplest part first. So for this case, we attach the LED in the pin 13 of the Arduino. So we need to power up this thing. So for this particular case, for the setup, we set the pin mode. So for the Arduino, this is the part you can set up the connected output to the pin. So you need to tell, because of Arduino pin is the GPIO, which is the general purpose input output. So it can be either the input or it can be either the output. So for the second part, digital write means that we will give the command of 1 or 0 to the output that was connected to the pin. So in this particular case, digital write 13 means that pin 13 we give the output of high. And then delay means that how long that it should hold the current state before it will execute the next state. So for this coding, it will be pretty straightforward. Means that the first one is digital write 13 high. So just give switch on the LED and then wait for 1 second, 1,000 milliseconds. So delay inside of this delay will be in millisecond. So 1,000 millisecond means that is 1 second. And then later on digital write the same pin low. So for this case is we put the same delay. So let's try to do the simulation. So in this case, you can see from here. So the LED will be blinking. It's quite straightforward. So we try to change. Let's say we try to change the coding. Stop the simulation first. So let's say if we change the delay, this thing maybe 500, 0.5 seconds. So the same thing with the second part, which is 500 millisecond, which is 0.5 second. So we do the simulation. So means that in this case, the LED will be blinking much more faster. So we change to another value, 100. So 100. So start the simulation. So it will be blinking much more faster. Okay. So there is the first part. So let's say we wish to, let's say we change a bit in our setup here, means that we put some sort of the button as an input. When we press the button, the LED will be light up. When we release that thing, it will be switch off. So let's do that in our second part. So how we can do that? First thing first, we need to select the component. So let's go to the basic component. So we need to put the let's say I use the breadboard. Just put the breadboard near this part. Okay, we have the breadboard, and then we need some button, push button. So okay, we have the push button here. So for the breadboard, if you still remember, so all the things here will be connected. The horizontal line is connected, but the vertical line is not connected. So when you click the protoboard, so you can see this is all the thing that was connected. So the same thing when you click this part, so this thing all will be connected. Okay, so now we have the push button. So now if we want to connect the push button to the Arduino, so usually the Arduino Arduino has the internal pull-up resistors. So means that you can use the internal part of the resistors, but most of the ESP, ESP32, ESP is another variant of the ESP. So most of the board does not have any internal pull-up. So what you need to do is that when you want to connect any input to the board, so you need to use the pull-up resistors, the external pull-up resistors. So I will show you in this part how we can connect input to the Arduino by introducing our pull-up resistor. So for this case, to connect to the pull-up resistors, we need to put one resistor. So for this particular case, let's say we rotate this component first, and then put the component in the breadboard. Okay. So for the push button, when you press the button, this thing will be connected. Once you release that thing, this thing will be unconnected. So what you can do is that this part, for the one part of this push button, so we can connect this part straight away to the grounding. So in this case, the ground will be so this is the ground connection. So let's say I use another ground connection here. So select this grounding connection and then straight away put it in here. Okay, so just connect this thing straight away to the grounding, and then secondly, another part of the push button, we just connect that straight away to the 5 volt. Okay, put it here and then connect it nicely. Okay, so we have connect this thing, and then the next step what you can do is that you need to select which part of the GPIO that will be used as an input. So let's say in this case just select pin number D10. We select that thing as an input. So for the pin number D10, we need to connect this thing to this part. So based on this connection, so let's say if the button is not connected, means that this pin will be connected to the ground. So for this case, the value will be 0. So once you press this button, so the 5 volt will be connected to this circuit. So the Arduino, since you have some resistor here, so the Arduino will read the input as the 5 volt. So for this particular case, once you press this thing, the pin 10 will be trigger high. So it can be used, the condition can be used to control the LED. Okay, so we are settled in terms of our hardware arrangement. So let's go to the coding part. So we will utilize most of the same coding structure. So for this case, let's say another part you can programming, you can use some define notation in order to define some pin or some sort of the pin output or pin input. So for this case, let's say I just put the button 1 as the pin 10. So in this case, we can call the button 1 in the subsequent part of the programming, so that the program will know the button 1 value will be equal to 10. So we have defined the button 1 function. So the next part is for the setup. So the same thing, we need to tell the Arduino that this button is actually input. So we just give the assignment of that thing. So it means that in this case button 1 will be input. So if you use the Arduino Mega or whatever, you can just change this thing to if let's say your Arduino has the internal pull up, you can change this thing to the input pull up, something like that. But in our case, we just use the external resistors as the pull-up resistors to get the input. So the second part is settled. So we assign the pin to the input. So now Arduino know that pin 10 belongs to the input. So the next part is that we need to ensure that the Arduino can read the state, because of the state is either high or low for pin 10. So let's say I just give the integer, let's say the button 1 state. Button integer means that the value will be 0, 1, means that no floating point. So for this case, if button 1 state, you need to read the digital status of pin in 10. So if you wish to digitally read the information, this is the digital write. So we have the digital read function. So we can just type digital read and then our button. So our button is the button 1. Okay. So now for this part means that the Arduino will read the status of the button 1, means that they digitally read the status in the pin 10. So it can be either high or low. Okay. So the next part, we need to put some condition function to ensure that whether this thing will be high or low. So if the button 1 state, So in the condition branching, you need, if you want to say it is equal, so you need to give this type of the notation. Means that this is the double equal function. It means equal in the condition function. Whereas if the normal function, if we just put equals, it means that the value in the left side will follow the value in the right side. If you put the double equal, so for this function means that it will check the condition state. So in this case, if the button one state is high, so what we need to do for this case? So let's say if digital state is high, so we just say the digital write 13 high. So we can just comment this part, and then the next part else, this part which is the digital write when 13 will be low. So for this simple coding means that if we press the button one, it will be switch on. If we release that thing, then it will be switch off. So let's try this part. Okay, so we have some error here. In function void loop, the error button one was not okay. Button one is not declared. Button one state. Button one. Button one was okay in this code. Okay, let me check first. Button one. This is supposed to be BU. Okay. Okay, let's start the simulation. Okay, now everything is okay. So just some mistake. Supposed to be BU instead of BO. So if you press this button, it will be switch on. We release that thing, and then it will be switch off. So the same thing. If we repeat the process, press that thing, and then release that thing, press that thing. Okay, please. So that will be the first function. It's quite straightforward. So in this case, we have covered up most of this part, which is we use the digital write, we use the digital read, and then we use the if statement. So this will be the first part of the coding in which we utilize this thing. So I would like suggest you later on to test the functionality. You can add another LED, and then you can try to create the new part, new programming, or let's say for this part, let's say you can try with the different functionalities so that it can works well. Okay, that's all for the first part. So in the latter part, we will use a different type of the setting.